Welcome to our channel Circuits Analytica. In this video, we will discuss a tutorial on mesh analysis. For the following network, find power dissipated by the 4 ohms resistor. First of all, let us mark the loops as 1 and 2. Mark the mesh currents as Ix and Iy. According to Ohm's law, voltage drop across 3 ohms resistance is equal to 3 into Ix minus Iy. Voltage drop across 4 ohms resistance is 4Ix and voltage drop across 5 ohms resistance is 5Iy. Applying KVL for loop 1. There are 4 voltage terms in loop 1. One independent voltage source, one dependent voltage source, and voltage drop across 2 resistors V3 and V4. Moving in the clockwise direction considering 4 volt, as we are moving from positive potential to negative potential, minus 4. When we consider the voltage source by the dependent voltage source of value 2I1, as we move from negative potential to positive potential, that should be taken as positive plus 2I1. Voltage drop across 3 ohms resistance should be taken as negative as we move from positive potential to negative potential. And voltage drop across 4 ohms resistance also should be taken as negative as we move from positive potential to negative potential. So applying KVL for the first loop, we will get minus 4 plus 2I1 minus V3 minus V4 is equal to 0. According to Ohm's law, V3 is equal to 3Ix minus 3Iy and V4 is equal to 4Ix. As I1 is equal to Iy, the equation minus 4 plus 2I1 minus V3 minus V4 is equal to 0 becomes minus 4 plus 2Iy minus 3Ix plus 3Iy minus 4Ix is equal to 0. Rearranging the terms, we will get minus 7Ix plus 5Iy is equal to 4. Equation number 1. Applying KVL for loop 2. In loop 2, there are 3 voltage terms. Voltage drop across 3 ohms resistance 3Ix minus 3Iy. Voltage drop across 5 ohms resistance 5Iy. And voltage source of value 1 volt. So when we move in the clockwise direction, if we consider V5 as the first voltage term, as we move from positive potential to negative potential, V5 should be taken as negative minus V5. When we consider 1 volt source, as we move from positive potential to negative potential, this 1 volt source should be taken as negative minus 1. When we consider voltage drop across 3 ohms resistance, as we move from negative potential to positive potential, that term should be taken as positive. So applying KVL, we will get minus V5 minus 1 plus V3 is equal to 0. Rearranging the terms, we will get V3 minus V5 is equal to 1. 3Ix minus 3Iy minus 5Iy is equal to 1. Rearranging the terms, we will get 3Ix minus 8Iy is equal to 1. Equation number 2. So we have two equations. minus 7ix plus 5iy is equal to 4, equation number 1. 3ix minus 8iy is equal to 1, equation number 2. Solving these two equations, we will get ix is equal to minus 902.43 milliampere and iy is equal to minus 463.414 milliampere. We are asked to find power dissipated by 4 ohms resistance. Power dissipated by 4 ohms resistance is given as P4 is equal to Ix square into 4, as Ix is the current which flows through 4 ohms resistance. So P4 is equal to minus 902.43 milliampere square into 4. So we will get P4 is equal to 3.2572 watts. So power dissipated by 4 ohms resistance is equal to 3.2572 watts. Thanks for watching Circuits Analytica. Enjoy learning.